Strange glass fragments scattered across the deserts of Australia are evidence of an ancient meteorite impact that scientists had not previously noticed. According to a new analysis led by Agnès Mussolino, a geologist from Aix-Marseille University in France, tiny glass spheres found in southern Australia contain a melted composition not found anywhere else in the world. Researchers say these glasses, named ananguite, were formed by a massive impact that occurred about 11 million years ago. Interestingly, geologists have not yet found any trace of the impact crater that would have been created by this event. Nevertheless, the event was powerful enough to leave behind mineral traces that remain identifiable for millions of years. Fred Jordan, a geologist and chemist at Curtin University in Australia, says, "These glasses are unique and record an ancient event we were unaware of. They formed when an asteroid struck Earth, melted surface rocks, and scattered meteorites thousands of kilometers away. These tiny glass fragments are like time capsules from the depths of our planet's history." What makes this discovery even more fascinating is that despite the enormous intensity of the impact, scientists still haven't been able to find the crater. The vast, barren deserts of southern Australia are full of small glass fragments called tektites, scattered across the ground. These glass pieces are actually products of a massive impact that occurred millions of years ago when a giant meteorite struck Earth's surface. Tektites were formed by the melting of Earth's surface rocks due to the heat and pressure of meteorite impacts, then dispersed into space as tiny glass droplets. The distribution area of these impact glasses, known as the Australasian strewn field, is a region where glasses are widely found across Southeast Asia and Australia. Tektites discovered in Australia from this field are called australites, and because the main impact occurred relatively recently, they are abundant in this region. According to Science Alert, in 1969, NASA scientists Dean Chapman and Leroy Shieber conducted a chemical analysis on 530 australites. Among these samples, they found 8 glass fragments whose mineral composition differed from the rest. Researchers considered this difference remarkable and suggested that these 8 pieces may have formed in a separate impact, but no one pursued the matter further. Mussolino and her colleagues decided to re-examine these unusual samples to understand the cause of the differences. The original samples were not available for re-analysis, but fortunately Chapman and Shieber had provided precise chemical descriptions of them. The main differences included lower silicon dioxide content and higher amounts of iron, magnesium, and calcium oxides. They also had greater density, stronger magnetic properties, different bubble patterns, and distinct ratios of rare elements. Using this information, researchers examined the australites collection at the South Australian Museum and found 6 new tektites that matched the mineral signatures of the earlier unusual samples. The chemical composition of these ananguites clearly shows they were formed by an impact that occurred in a different part of Earth's crust compared to the one that created the Australasian strewn field. This means that unlike other tektites scattered across the Australasian field, which are linked to a single impact in Southeast Asia and Australia, these new glass fragments were formed by a separate and distinct impact with Earth. To confirm, Mussolino and her colleagues performed argon dating on 2 of the 6 new samples. Jordan and other researchers had used the same technique in 2019 to date tektites in Southeast Asia and Australia, which traced back to about 788,000 years ago. The research team concluded that the new ananguites are 11 million years old, significantly older than the tektites. There are several possible reasons why the crater that produced the ananguites may have disappeared. One explanation is severe erosion and climate changes in the region, particularly since about 33 million years ago when Central Australia began to dry out. During this time, natural forces such as wind, rain, and temperature changes gradually eroded geological structures and altered many surface features. It is also possible that the impact crater was misidentified as volcanic features in certain areas, such as Papua New Guinea. In these regions, similar formations have appeared, which may have caused confusion in recognizing the true impact crater. In their paper, the researchers wrote, "Systematic geochemical and petrographic differences between western and eastern ananguites, which still require confirmation with additional samples, may help identify the exact location of the impact." These differences could provide clues about the region where the collision occurred. Another possibility is that the impact crater has been buried over the past 11 million years due to natural processes such as erosion or tectonic movements, leaving no visible trace on Earth's surface.